is. Okay, now we're going to go from that to some cost curves. Now this is showing me variable cost. So variable cost is just the cost that changes with output. That's what the variable means. So let's go back to our production function that we're using where we have increasing returns. Now remember, as I add input here, I'm getting more output and I'm increasing it at an increasing rate in the beginning. And so now I'm going to be measuring output over here. This is output on this axis. So if I just use quantity, I'm talking about output. And I want to know what's happening to cost as I change output. So in the beginning, when I have increasing returns, I'm getting more and more output when I add one more unit of my variable input or labor, which means in this range, the addition to cost is getting smaller. It's going to cost more to make more. It always is going to cost more to make more, as long as that cost is positive. But the addition to cost is going to get smaller because for a given unit of output over here, when this curve is really steep, it's going to take me a smaller quantity of labor than it does over here. So in this increasing returns range, because I'm getting better and better at producing output, in other words, the addition to cost is going to get smaller and smaller to get that next unit of output, which is why the curve bends this way, just bends the opposite way, because we're increasing at a decreasing rate if we have increasing returns to our variable input. So in other words, for one quantity of output in the beginning, we're going to have a certain large increase in cost. But as long as I'm in my increasing returns range, as this is getting flatter, right now I'm going to get that next unit of output, that addition to cost is smaller. So it's taking me less and less inputs, right? Fewer units of labor to get this quantity of output. It's taking fewer units of labor, which means this increase is going to be smaller over here, right? As long as I'm in my increasing returns range. So as soon as I hit this inflection point over here, now I've hit diminishing returns. And when I hit diminishing returns in my production function, the increase in output is getting smaller and smaller. Marginal product is falling, which means the increase in cost is getting bigger and bigger. It's becoming more and more costly. So as this gets steeper, it's becoming more and more costly to get that next unit of output here. I'm going to have a bigger and bigger increase in cost to get that unit of output. So this is variable cost, so it's starting at zero. If I produce zero output, I have no variable cost. Increasing returns range, diminishing returns range to variable cost. So then I just have to add my fixed cost, the cost that doesn't vary with output. So that's just some cost that is not varying with output. So the cost of my rent for the year, or something that doesn't vary with output. And then so all I'm going to do is add that on top of variable cost to get total cost. So I'm just adding some fixed number to get total cost, which is why it has the same shape as variable cost. So this is the total cost is just, now instead of just the change in the variable cost, the change in total cost, it's including that fixed cost, but fixed cost is not varying with output, so it has the same shape, the same slope as the variable cost curve. The only difference, this vertical distance here at every quantity, is the fixed cost. So we're not starting at zero, because even if you produce zero output, you're still going to have that fixed cost. So just shift it up by the amount of that fixed cost. Okay, now we can go from this to our most important per unit cost curves. So these are total cost curves. We now are going to get some per unit cost curves, which is what we're going to need when we start talking about firms and different types of firms and their behavior. Okay, so marginal cost. So marginal is just the change in cost as we change output. This is quantity of output. So that's going to be the slope of actually either one of these curves, since they have the same slope. So variable cost is the cost that varies with output. That's what marginal cost is. Marginal cost is the change in cost as for a given change in output. And so that's what variable cost is. So it's the change in variable cost as we change output, and it's also the change in total cost as we change output, because again, these have the same relationship here. So if this is increasing at a decreasing rate, then the slope of this curve is the marginal cost. And so the marginal is falling in this range. If we have increasing returns, our cost is increasing at a decreasing rate, then marginal cost is falling in the beginning. So notice for these graphs, I'm not going to try to get this all the way to zero because I don't want to worry about what's going to happen for that first fractional unit. So by drawing these continuous curves, I'm really assuming that we can pick kind of any fractional unit. So I could produce the first 0.001 units of this product, and so I don't want to have to worry about what that first 0.0001 unit is gonna cost me. So I'll kind of start off that 0 point. But the important point is that this is falling at first. So the addition to cost is decreasing, and now this point corresponds to when we hit diminishing returns. Because if that marginal cost is falling, we're in the increasing returns range. As soon as that starts to rise, we've hit diminishing returns. So that corresponds to this point, and it also corresponds to this point where we hit diminishing returns. So then marginal cost is rising again. Draw it as a curve, a straight line, it wouldn't really matter so much. But as long as this is rising, showing that we've hit diminishing returns. Okay, now we're going to go back to what we were doing with averages. So it seems like we have a million different cost curves here, but if you understand what's going on, it's really not too bad. So again, pick a point in this falling section of this curve. So at some quantity, my marginal cost, the last unit of output, cost me that much to produce, or that much extra cost to produce, I should say. And I'm going to take an average. So this is just average of the variable cost. So the cost that changes with output, so it's the average of what's going on my marginal cost curve. And so if I take an average at some point here, well, I'm averaging in all the earlier units. Well, all the earlier units are higher, and so the average is going to have to be high, somewhere higher than that point. So the average is above this curve, and now I'm adding the next unit, whatever is going to be the addition to cost from the next unit. Well, I'm going to be dragging down the average because I'm adding units that are below the average. So even though I've turned up here, I'm still dragging down my average because I haven't caught up to my average yet. So the example that's often used in textbooks is like your test average. So I'm going to add the next test. My grades have been falling, which means my average is falling. Now I start making a comeback. My next grade is higher, the one after that is higher. But if I haven't caught up to my average yet, my average is an 80, and I'm going to get 75, 76, 77. I'm still dragging down my average until my grades get high enough I can start dragging up that average. So that's what's going on here. So even though this is rising, if I'm still below the average, I'm going to be dragging down the average. As soon as what I add is above the average, now my next grade's an 85, right? Now I'm going to be finally dragging up my average. So that's why minimum average variable cost, right? That's where marginal cost is gonna hit it. So it always hits right there at the minimum, because as soon as what you add is above the average, you're dragging up the average. This is the same exact kind of reasoning we used here to construct this average curve. So this is really actually the mirror image of what's going on this curve with these two averages, because we derived it from the same production function. So now we have average variable cost. So remember, we have three different kinds of costs here. These are all our totals. We have our variable, the cost that varies with output. We have this fixed cost, the cost that doesn't vary with output, and the total is just the sum of those two. I just added my variable and my fixed. That equals my total. So we have to do the same kind of thing when we talk about our per unit costs.